Hello, my dear students. Today we are going to continue our discussion on chapter 3. We are going to continue our discussion on the factors affect the rate of chemical reaction. Last time we discussed the two factors, which are the nature of reactants and the concentration of the reactants. Today we are going to continue the rest of these factors, and we are going to discuss the factors that affect the rate of chemical reaction at equilibrium. So let us start. My dear student, now we are going to discuss the effect of temperature. The rate of chemical reaction is directly proportional to any rise in temperature. The rise in temperature leads to what? Increase the kinetic energy of the molecule of the reactants and increase the velocity of molecules and the rate of collision between them that reach the activation energy of the molecules with the amount of energy enough to break the bonds in the molecules of reactants. Therefore, the rate of chemical reaction increases. So we have good reason in this point. In summer, food goes rotting quickly if we left it in the air, because in summer the temperature rises and this speeds up the rate of chemical reaction and the composition increases, and so the food spoils and goes rotten quickly. Another gives reason in this point. Food is cooked quickly in the pressure cooker that is called presto. The reason for that because the pressure of the water vapor increases, causing an increasing in temperature, and this happens in short time, so the rate of chemical reaction required for cooking increases. Now we are going to discuss what do we mean by the activation energy. It is the minimum amount of energy required to begin the chemical reaction. In other words, we can say it is the minimum amount of energy gained by a molecule to react at collision. So we are going to define what do we mean by activated molecules. They are molecules which have kinetic energy that equals or exceeds the activation energy. Now, my dear student, we are going to discuss the collision theory. It assumes that the reacted molecule must have minimum amount of energy called activation energy that needed to collide the molecules with each other for breaking their bonds in the reactant, and so the chemical reaction takes place. My dear student, notice that raising temperature for 10 degrees Celsius make to double the rate of chemical reaction. Now we are going to discuss the effect of pressure. If the reactants or products found in gaseous state, we express them by using their molecular partial pressure. For example, the preparation of ammonia gas in industry. As the equation proceeds on the screen, nitrogen plus hydrogen giving in high pressure and high temperature and cooling, it gives ammonia gas. And here the reaction is exothermic and delta H is negative equal 92 kilojoule. Here, my dear student, 4 moles for the reactant, 1 mole of nitrogen and 3 moles of hydrogen react to form 2 moles from the product ammonia gas. The formation of ammonia gas is accompanied by decrease in the number of moles and so decrease in their pressure. So we have to define what do we mean by equilibrium constant Kb. It is the ratio between the rate constant of forward and backward reaction depending on the partial pressure of the reactants and products. So my dear student, Kb is used to express the equilibrium constant in the gaseous reaction. My dear student, we have to write the equation for the equilibrium constant Kb for the formation of ammonia gas. Kb equals the pressure of ammonia gas power 2 over the pressure of nitrogen times the pressure of hydrogen power 3 power their number of moles in the balanced equation. For example, calculate the equilibrium constant Kb for the reaction N2 plus 2O2 gives an equilibrium 2NO2 given that the pressure are 2, 1 and 0.2 atmospheric air for the gases NO2, O2 and N2 respectively. Solution: Kb for the reaction equals the pressure of nitrogen dioxide power 2 over the pressure of nitrogen times the pressure of oxygen power 2. So Kb equals 2 power 2 over 0.2 times 1 power 2, so it gives 20. So we have give reason in this point. Heating cylinders of butagaz from outside is very dangerous. The reason for that because heating process converts the butagaz from the liquefied state to the gaseous state. So the volume of the gas increases and causes high pressure on the cylinder walls leading to its explosion. Now, my dear student, we are going to discuss the next factor which affect the rate of chemical reaction, which is the effect of catalyst. The catalyst definition: it is the substance which causes a change in the rate of chemical reaction without itself being changed. So, my dear student, catalyst increases the rate of chemical reaction by decreasing the activation energy of the reactant. So, we have give reason in this point. Catalyst does not affect the rate of chemical equilibrium because it increases the rate of both forward and backward direction by the same proportion. So it decreases only the time needed to reach the equilibrium state, or we can say it reaches the equilibrium fast. We have give reason in this point. Catalysts have an economical importance. The reason for that because it decreases the activation energy of reactants, so increases the rate of chemical reaction. Thus, it saves a lot of money paid for using fuel to raise the temperature. My dear student, the catalyst may be an elemental metal or oxide or its compound. We have give reason in this point, my dear student. The catalytic converters are connected as part of the car exhaust system. The reason for that because they change the gaseous combustion products which cause air pollution into safe products. Now we are going to discuss the enzymes as catalysts. Enzymes are high molecular weight proteins produced in the living cells. Enzymes, my dear student, are used as catalysts in the several biological and industrial processes. Now we are going to discuss the last factor which affects the rate of chemical reaction, which is the effect of light. Some chemical reactions are affected by light, such as photosynthesis. Here, the role of chlorophyll in photosynthesis process. The chlorophyll absorbs the light energy and acts as catalyst to form the carbohydrates from water and carbon dioxide. Here, another example for the effect of light, which is the photographic films. They contain silver bromide in gelatinous layer. When light falls on the photographic film, here the silver ion gains an electron from the bromide ion, changing silver ion to silver metal. This reduction process makes the silver be neutral, so the silver is absorbed by the bromine in the gelatinous layer. When the intensity of the light increases, the rate of formation of silver increases. My dear students, we have reached to the end of factors that affect in the rate of chemical reaction generally, which are nature of reactants and concentration and the effect of temperature and the effect of pressure and the light and the catalyst. Now we are going to discuss another factors which affect the rate of chemical reaction on equilibrium, and we are going to discuss rule which is very important, which is Le Chatelier principle, which shows the effect of the rate of chemical reaction. That reaction happens at equilibrium. Let us show. Le Chatelier principle. It states that a change in any of the condition of chemical reaction at equilibrium, such as concentration, temperature, and pressure, the reaction will be shifted in the opposite direction of this change. These factors, my dear student, are classified as following: the concentration, temperature, and the pressure. We are going to discuss each one. We are going to discuss first the concentration of the reactants. Increasing the concentration of the reactants or decreasing the concentration of products. Here the reaction shifts in the forward direction as formation of products increase. So the concentration of the reactants decrease and the concentration of products increase. Here, my dear student, on decreasing the concentration of reactant or increasing the concentration of product, the reaction shifts in the backward direction in the formation of the reactants. So the concentration of the reactants increase and the concentration of the products decrease. We are going to show an experiment to show the effect of the concentration on the rate of chemical reaction at equilibrium. On adding iron 3 chloride solution, which has yellowish color, to ammonium thiocyanate, which is colorless solution, the solution becomes red color, and we have given reason for this point. Due to the formation of iron 3 thiocyanate, which has blood red color. As the equation proceeds on the screen, iron 3 chloride, which has yellowish color, to ammonium thiocyanate, which is colorless, it gives in equilibrium iron 3 thiocyanate, which has blood red color, and ammonium chloride is formed. Here, my dear student, when adding excess of iron 3 chloride solution, the intensity of red color increases, and we have given reason in this point, because according to Le Chatelier principle, when the concentration of the reactant increases, the reaction shifts in the forward direction to forming excess amount of iron 3 thiocyanate. And when adding an excess of ammonium chloride, the intensity of the blood red color decreases, and we have given reason for this point. Because according to Le Chatelier principle, when the concentration of products decrease, here the reaction shifts in the backward direction, so decreasing the amount of iron 3 thiocyanate. I'm going to discuss the second factor which is going to affect the chemical reaction at equilibrium, which is the effect of temperature. If the reaction is exothermic, as shown on the screen, reactant gives product and heat is released, or we can write it reactant minus heat gives a product, or we can write it as following: reactant gives the product and delta H is negative. Here the increase in temperature shifts the reaction in backward direction according to Le Chatelier principle, and the decrease in temperature shifts the reaction in the forward direction according to Le Chatelier principle. Here, if the reaction is endothermic, as shown on the screen, reactants gain heat by heating and gives a product, or we can say reactant gives a product minus heat, or written as following: reactant gives a product and delta H is positive. Here the increase in temperature shifts the reaction in the forward direction according to Le Chatelier principle, and so the decrease in temperature shifts the reaction in the backward direction according to Le Chatelier principle. So we are going to make an experiment to show the effect of the temperature on the rate of chemical reaction at equilibrium. As shown on the screen, get a flask containing nitrogen dioxide gas which has a reddish brown color at room temperature, as the following animation show. My dear students, in this experiment we bring 3 test tubes containing nitrogen dioxide gas in equilibrium with its dimer nitrogen dinitrogen tetraoxide. Here, my dear student, we have to put each one in 3 different beakers, one containing tap water and the other containing hot water and another one containing cold water. We find that at room temperature both of nitrogen dioxide NO2 and dinitrogen tetraoxide N2O4 are present, so the solution has brown color, not intense, but we are going to put it in cold water and hot water. The reaction here is exothermic. That means that nitrogen dioxide, 2 molecules forming dinitrogen tetraoxide, and the heat is released. So when putting it in hot water, the reaction shifts backward, and so more nitrogen dioxide will be formed, and so the intensity of red color increases. While in cold water, it means the reaction shift in forward direction, forming more dinitrogen tetraoxide, which is colorless, and so the color will be faint in the test tube, as shown on the screen. As the equation shown on the screen, 2NO2 reddish brown color by cooling gives N2O4 dinitrogen tetraoxide, and heat is released as the reaction is exothermic. So when the flask is cooled, it becomes colorless as the reaction shifts in the forward direction, forming dinitrogen tetraoxide, which is colorless. As the equation proceeds on the screen, when cooling the nitrogen dioxide, it forms N2O4, which is colorless, and heat is produced. And when the flask is in hot water, it becomes reddish brown color as the reaction shifts in the backward direction, forming more reddish brown NO2. As the equation proceeds on the screen, dinitrogen tetraoxide on cooling, it gives nitrogen dioxide gas which has reddish brown color, so the intensity of the red brown color increases. So my dear student, now we are going to discuss the relation between the effect of temperature and Kc in the exothermic and endothermic reaction. If the reaction is endothermic, according to Le Chatelier principle, the increase in temperature shifts the reaction in the forward direction, so the concentration of product increases, so leads to an increase in the equilibrium constant Kc of the reaction and vice versa. So my dear student, as the temperature increases, Kc increases, so it is direct relation. While if the reaction is exothermic, according to Le Chatelier principle, the increase in temperature shifts the reaction in the backward direction, so the concentration of the product decreases, so leads to decrease in the equilibrium constant Kc of the reaction and vice versa. So the temperature increases and Kc decreases, so it is inverse relation. Now we are going to discuss the third factor which affects the effect of pressure. If the substance which enters the reaction and resulted from the reaction found in the gaseous state, we express them by using their partial pressure. If the number of moles or the volume of the reactants equal the number of moles or the volume of the products, the pressure has no effect on the equilibrium. As the equation proceeds on the screen, example for this case. Here carbon monoxide reacts with water vapor giving carbon dioxide and hydrogen gas. Here 2 moles of reactant and 2 moles of the product. So here, my dear student, if the number of moles are equal, has no effect. The next case here, my dear student, if the number of moles or the volume of reactants are greater than the number of moles or volume of product, here, my dear student, the increase in the pressure, which means decrease the volume of container, the reaction shifts to the forward direction according to Le Chatelier principle. So the concentration of the reactant decreases and the concentration of the product increases. And the decrease in pressure, here, my dear student, or increase the volume of container, here the reaction shifts in the backward direction according to Le Chatelier principle. So the concentration of the reactant increases and the concentration of product decreases. For example, here nitrogen plus 2 moles of oxygen gives 2 moles of nitrogen dioxide gas. Here 3 moles from the reactants form 2 moles of the product. So here the pressure has decreased when going to forward direction. So the increase in pressure or decreased volume of container shifts the reaction in the backward direction according to Le Chatelier principle. So the concentration of nitrogen and oxygen gas decreases and the concentration of nitrogen dioxide gas increases. And the decrease in pressure increase the volume of container, shifts the reaction in the backward direction according to Le Chatelier principle. So the concentration of nitrogen and oxygen increase and the concentration of nitrogen dioxide gas decreases. But my dear student, if the number of moles of or volume of reactant is less than the number of mole or volume of products, the increase in pressure decreases the volume of container, shifts the reaction in the backward direction according to Le Chatelier principle. So the concentration of the reactant increase and the concentration of product decrease. And the decrease in pressure or increased volume of container shifts the reaction in the forward direction according to Le Chatelier principle. So the concentration of the reactants decrease and the concentration of products increase. For example, 2NO2 gives N2 plus 2O2. 2 moles of the reactant form 3 moles of the products. So the increase in pressure, decrease in volume of container, shifts the reaction in the backward direction according to Le Chatelier principle. So concentration of nitrogen and oxygen decreases and the concentration of nitrogen dioxide gas increases. And the decrease in pressure increase the volume of container, shifts the reaction in the forward direction according to Le Chatelier principle. So concentration of nitrogen and oxygen increases and the concentration of nitrogen dioxide decreases. My dear students, we have reached to the end of our program today. I hope you understood all the points and problems that we discussed today. So till we meet again, my best wishes for you.